let's move ahead. So now in this data, we understood what to think of before we split this data. So this pre-processing, guys, is known as feature engineering. So now I am introducing you to a very important term, which is feature engineering. So in the field of data science or machine learning, whenever you have the data, you gather the data, the next step is to do feature engineering. Feature engineering, as the name suggests, doing some engineering on the features. Features means your input side. You have to do feature engineering, right? That includes all those steps which I was talking about, the pre-processing steps. And that's where we take help from data engineers. That data engineers, when they are giving us the data, we upfront tell them that these are the feature engineering steps you have to do, so that the data that a data scientist will receive, data scientist can directly use that data. They don't need to invest much efforts into feature engineering. Okay, that's where it's a collaboration of two areas, I would say. Data engineers take care of all these feature engineering and data cleaning, and then the data that they give to data scientists is already in a clean shape, so that data scientists can directly start from the train and test split phase and start training and testing the model, rather than investing their time in feature engineering. Normally 50 to 60% time of every data scientist goes in this part, or even more time goes into cleaning the data, gathering the data. So that's where we say, if data engineers can help us with all these, data scientists can directly focus on the machine learning. Even a data scientist can also do feature engineering. They do in most of the cases. So here what we are doing, we are trying to check for the null values. You guys are following with me? I am not going into the very specific implementations, how I am doing it, but telling you what I am doing. Okay.
Yes, Rahul, we are with you.
Okay. So in feature engineering, here I am checking in the data frame, is there any NA value? Is there any null value? So for every column, it is saying 000, means there are no null values or no missing values in the data. So at least we are done with the missing value checks. But are there any duplicates? So guys, this is another step, right? You need to check whether your data frame contains any duplicates. So there are these two records which are duplicate, record number 195 and 581. These are duplicate records. So we need to remove one of the duplicate values and keep only one. Because consider even what the problem will happen. When you are training the model, you will be training the model on this record 2 times. So that means the model will be slightly biased towards this combination of data because it has been trained 2 times on this. So duplicate should also be removed. So we have the clean data frame. We have checked the missing values. We have checked for the duplicates, but still we haven't done the encoding, right? Encoding is yet to be done. Scaling is yet to be done. We can skip scaling here because it's almost on the normal scale, but target can be scaled if we want, but we will talk that later. Yeah, but the first thing is encoding. So here we are talking about data encoding. So in the field of Python, as we will be progressing in the next sessions, I will teach you about different encoding strategies, label encoding, ordinal encoding, one-hot encoding. Okay. But this particular case, I'm using label encoding. Uh, what is label encoding? Label encoding is the simplest one. It will take the values and it will simply assign them indexes. Like, okay, 0, 1, 2, and 3. So whatever are the distinct values in that column. So let's say the region column, uh, we had all these different values, northeast, northwest, like this. It creates an array and assign them indexes like 0, 1, 2, 3. And every value, wherever there was northeast, it will be replaced by 0. Northwest will be replaced by 1, 2, and 3, so on. So let's look at this, what we are doing at a high level. It's a label encoding class. I'm creating an object of this class here, label encoder class. Within this object, Python object, we have a fit function. I am calling this method. What I am passing to this method is the column, the region column. And finally, this method fitted and transformed. So from these values, I get final transformed values. For every region value, it is finally converted into its corresponding 3, 2, 2, 1, whatever it is. Similarly, we will be doing it for the gender column. Okay. So from the original sex column, I am creating sex underscore encoder column. So these naming conventions, guys, are very important, or you should use logical naming conventions like I am saying sex underscore encoder so that I know that this is encoded, smoker underscore encoder. So from the smoker column, I am creating the encoded column, and likewise. And finally, this data frame, which I get, I am showing you that along with the original sex column, I have the sex encoded column, uh, the smoker column, I have the smokers encoded column, right? And regions, I have the regions encoded column. Now what I need to do, I need to drop these columns, right? The original columns, they are not needed. So what I will do, I will drop from this data frame, I will drop these columns of from this XS1. But then I am also talking about scaling, right? There are different scaling classes also. Minimum, maximum scaler, absolute scaler, robust scaler, standard scaler. Standard scaler is one of the most famous and the best scaling strategy. We will talk about that in detail uh, some other day. But again, I am using uh, Python's sklearn package, guys. This is the single most important package of Python to do machine learning. sklearn, scikit-learn package. From the pre-processing, I am doing this scaling. If you go up also, even the encoding is part of pre-processing sub-module, right? So within this bigger module, this is a sub-module, pre-processing. And I was using encoder classes, then there are scaling classes, right? There are missing value imputation classes. A lot of things are available to us. And what I am scaling here, I'm scaling the age. So if you look at this data, guys, I can scale age also, BMI also. Why I am doing so? Because if you look at the other columns, they are now in the range of 0 to 1, almost 0, 1, 2, 3, like that. So I can even scale my BMI value also and age also so that it comes within a range of 0 to 1. So this is standard scaler, guys. It converts every value between the range of 0 to 1. Uh, we will talk about that in detail. And finally, I have my uh, encoded data frame, which is scaled also. So if you look at this data, right, this is my final data, which is encoded. And then I haven't done any scaling in this data. See, age and BMI is there. But if interested, you can do that. This is my target. Expenses column is the target column. But now remember what we were talking. The next step. Once the data is cleaned and everything is done, train test split. So we have a train test split method available using which we are splitting our data, and see here we can decide the test size. So 30% of my data goes as test, so that means 70% is training data. So this data frame will be splitted such a way that test data size is 30%, okay, and the train data is 70%. This splitting method takes care of random shuffling statistically rather than sequential splitting. So our data will be very good representation of the actual population. This random state is just to control the splitting which is happening. Okay, so now the output will be train data and test data. So you got the train data here and you got the test data. You can see 935 records are part of your training data. And here you can see the record numbers also, which records, and see, they are not in a sequence. They are shuffled. Otherwise they would have been in a sequence. It's shuffled, that randomly you are getting the records in training and randomly you are getting the records in test. So that's how you can see that this train test split is splitting data into 935 records going here and 400 records going here. And then it's a random shuffling, not a sequential shuffling, because the original data indexes are not in sequence, right? Okay. Now you have the train data, you have the test data. Now you have to start the modeling part.